Okay, hi everybody. I'm Florent Guerin. I work for DocDoku. We are a small company around 20 people. We are based in France, in Toulouse and also in Paris. We are focused on developing digital application for the industry sectors. So we are committed to the open source, and we make DocDoku PLM, which is a product lifecycle management tool, which I will present you today. So we work on mostly the technology we use is HTML5, Java. We use big data technologies, WebGL, PLM, obviously, IoT also, and we develop application for the industry. So about me, I'm the co-founder of the company. I have 20 years experience working on IT software. I'm mostly a Java guy, so Java or GEE, Enterprise Edition. And I wrote a book about Android. So today, my presentation will explain you what PLM is. PLM is a very transversal software. It's about aggregating all the data around a product. So this is very large, and by product, I mean an aircraft, a car, a vacuum cleaner, or anything we can build, okay? So it's a very transversal application that can involve lots of departments inside the company. At the heart of PLM solution, there is a PBS. The PBS is a central part of PLM. PBS is product breakdown structure. So basically, it's a breakdown, a hierarchical decomposition of a product from root assembly to sub-component. So let's take an example. Let's take a pizza. Okay, everybody know what a pizza is. So this is the example I will follow on my presentation. Imagine we just want to design our pizza. So what is a pizza? A pizza is made of several components. You have the dough, you have the tomato, banana, you have a gib. Okay, this is the first level BOM. BOM is bill of materials. So this is our first level. But because it's a hierarchical, the dough is itself made of salt, flour, water, and so on. So we have, it's a tree structure that can be very deep. Just to give you an example, Airbus A380 is more than 1,200,000 parts. So, and when I say part, I mean, I didn't mean instance, I mean unique part. So this is very deep and very huge. So every assembly link, we call it part usage link actually, is all data. And for example, you can specify the quantity. So we have each 5 ananas, and the quantity can be also expressed in liter, gram, or anything else. Okay. As you can see, you can have several designs to represent the same thing. For example, a car, you can use only one part usage link, and you link the structure of the car to 4 tires, or you can, if you want to distinguish, you can make 4 different links. It's up to you, it's your choice. It depends on if you want to carry various data on each link if you want to segregate or not. So you can choose what you want to do. Most of the time, we want to treat all the instances in the same way, so it's preferable to have only one part usage link and a quantity of 5. Sometimes we also have optional. The egg is optional, okay? You can make a pizza with egg or without, okay? So we define also on your PBS, you will design such a link which is optional. Sometimes also you have alternate link. You can replace the gib with chorizo on my example. So this is the same. You can have a car with 3 doors or 5s. Okay, you can select the number of doors. You can select the quality of the seat. So you can express and design all those things inside your PBS. At the end, finally, what you get is you have 150 bill of materials. 150 means is above 100. You have too much things. It's not a real product. It's a kind of abstract product which have all the various configuration, and it's not makeable. So to get a makeable product, you have to resolve, this is the term, you have to resolve your PBS. So how can you do that? Sometimes you have choices that may exclude each other. If you select, for instance, the open top, it's just an example. You cannot select the air condition, things like that. So you need also to design all these rules inside your PBS. Okay? So you have a huge PBS. Everywhere on the PBS, you can attach data. So you have you track the author, creation date. You can add custom attributes. This is very interesting to add custom attributes so you can perform calculation on your PBS. You could add a special attribute, a cost attribute on every component, and then after that you can simulate the impact of various configuration according to the cost. You can also attach attribute like the weight or the gravity center or things like that. Okay. The leaf component also could have geometry data. This is the 3D models of your component. On the link itself, you can attach data, description, quantity, and also position and rotation matrix, because if you want to represent in 3D-dimensional the whole product, you need to have it on the link. Okay, everything is managed under configuration. So we have an history of every modification. In our software, we use iteration and revision. Iteration is just a simple history of every single modification you made on the structure. And revision is the major, it's a major step. So iteration is 1, 2, 3, revision is A, B, C, and the whole identify the right, a precise version of a given part. Okay, so how can we go from a bloated PBS to a makeable product? There's two we offer two ways to do it in our software. Okay, so this is a more realistic example. It's an aircraft. So this is a part number. 100 is a part number. This part number exists in only one version, version A. We don't represent iteration because iteration is not a major step, so we always consider the latest iteration. Iteration is just for the history. This part is an assembly of two parts, 200 and 300. Okay, 300 has only one revision, revision A. 200 exists in two revision A and B. Okay, so this is our breakdown. So the question is, how can we capture a makeable product? How can we select it? So we can make a baseline. Baseline is basically a snapshot. It's exactly what we do in software. We create a tag on Git or a branch. It's the same. So you can take a snapshot, and here we have an example. Our baseline capture version A, version B of this part, etc. So this is very simple, clear. There's no ambiguity of what blueprints we will send to the manufacturing department. But it's not always easy to use baseline when you want to plan modification, because each time you need to take another baseline and so on. So this is not very useful. So it's adapted to a less formal processes. Another strategy is to use effectivity. Effectivity is another object that we attach to a specific revision. In our example, we add an effectivity. Effectivity means, okay, the number here is a root number. As you can see, we always have 100. How does that mean? That means and the number below is the serial number, okay? So if I will make, this is a product, this is the whole product that will go to production. If I make a part 100, which is the product, for serial number 62, it's an open, I will need to select revision A. Here, that means for serial number 1 to 5, we make them with revision A. And starting from serial number 6, okay, we will not use any more revision A, but revision B, okay? So this is another way. At the end of the day, we can resolve our PBS. If I ask the manufacturing department, okay, what is, how do you make serial number 5, or how do you make serial number 3? They know exactly which version to select. So at the end of the day, we got a resolved PBS, but it could be more interesting to use effectivity, because you can plan when you will push a revision into production. So it's perhaps more complicated to use effectivity. It's perhaps not as clear as which version of which subcomponent we'll use, but it's easier when you want to planify your production. Okay, so let's have a demo. I hope the network is network is not so good. Okay, so the screen quality is not very beautiful, but okay. On my left, this is the PBS. On the right, we can visualize the product. So, okay, the product have some network issues, so it didn't load the whole product, but we can see the engine. Okay, this is just an example. This is an aircraft engine. Okay. The representation is taken from CATIA. Okay, in our product you can support the most major CAD offering tools. We have converters for each of one, and we can convert it to be able to visualize them directly inside the browser without any plugins. So I have my structure here. I can open it. I know exactly where the engine is. This is my engine. I can open it. I can see additional data attached to it. It's just a PDF file. The download is very slow, but it's a PDF which documents the part. I can see there we have an alternate. We have two engines actually. We can select one or another. At the top of my product structure, I can select what we call the config spec. This is the algorithm that will be used to resolve my PBS. In this case, it's latest version, so I just visualize the latest version, but I could select baseline or a specific serial number, and then the whole things will change, the whole screen will change, and I will switch to a specific baseline or a specific serial number. As you can see, perhaps, have you noticed we have explanation mark here? Okay. That means when you have an explanation mark, that means a change has been made on a subcomponent. Okay. After the assembly have been checked. So we have an explanation mark. So we know that we have potential impacts on the assembly. Because we change a subcomponent, we need to check if there is something to change on the assembly or not. So the system gives you an icon, a specific icon, so you can, okay, validate, mark as verified, and add a comment to notice that you check there's no impact on this assembly. This is very useful when you have a large team with subcontractor, and when you reuse components on several products. And this is usually the case, because if you compare two aircraft, at the end of the PBS you have a common piece, so usually these parts are not specific to a product, to an aircraft. So if there is a change, we should notify all the assembly that there's a potential issue. Okay. It takes lots of time. What else? If I reopen, the network is too slow. Oh, this is another example, very simple. This is a drill. Okay. I can hide specific part. Okay. What is very interesting is also I can take a snapshot of my product at any time. So if I want to document it in a Word document, for example, what I can do also, I can start a digital mockup preview. This is very useful. I can invite somebody else, okay, some coworker, to join a room, a specific room, where we can exchange, we can chat, and where we can discuss on the design. We can then move or make some modifications, some rotation. Just this is not a permanent modification. This is just to make a review. This is very useful. All of this work only with standard HTML5 technologies. So it works on Mac, on Windows, on Linux. No need to install anything. What I can show you also is anytime, because PLM is about data, it's about managing data. Here I can create layer. It works like Google Maps, when you can add pin, okay? When I can add an information here, I can, okay, clash, there's some clash, okay, we need to change something. Okay, I will reduce my marker. I can select a color for my marker. I can have several layers. I can name them. Okay, clashes. So I can easily manage a huge quantity of data. Everything is placed in the right place. What also I can do, I can go back. Okay, so if I'm going back to this view, this is the part list. Okay, this is my collection of all the parts I use in all my product. This is my product itself. I can download it to a zip file. This is very useful because for the enterprise which has lots of subcontractors, we need to share the data. I can use a fine-grained ACL, so I can add specific rights on every part. I can also, very useful, use by tab, which lists for specific parts where it is used. So this is very useful. Sometimes also I can mark a given part as deprecated, mark as obsolete. So everywhere, if I just mark this part as deprecated, every product where the part is used will be also notified that it uses a deprecated and obsolete part, and the part cannot be reused again. So for companies that manage hundreds and thousands parts, this is very useful. If I want to take a snapshot, I can take a snapshot, a baseline. I can create a baseline of a product. Once I created my baseline, I can then create a real product with a specific, which is made of a specific part baseline. So this is the example. This is my serial number. Here I know this instance with this serial number is based on this baseline. And from that, I can also add specific data to this instance, because sometimes you have two products which is made with the same blueprint, but you have different data. For example, the settings could be different, so you can also attach this kind of data to a specific instance. Okay, just to finish, what I can show you is a function. I can create a user-defined function. It's a kind of map reduce algorithm where I select my product, okay. I can select a config spec. How will I resolve my product structure? So I can select latest version. And from that, I can make sum of an average. I can launch the calculation. So, okay, this is the weight of my product in ton. Okay, more than 300 ton. Okay, this is the aircraft. So it navigates the whole structure and make a sum on all the sum attribute. So this is very flexible because every people can use it the way he wants to sum the cost, to sum the weight, or whatever you want. Okay? So do you have any question? Yeah, exactly. So we can do it, okay? Once your product, okay, as I explained you, this is an instance of my product, okay? If I go to the navigation tree, okay, I can select a part, okay? And then I can add data, deliverable data. This is data which is specific to this instance, okay? So this is how the maintenance is made. You can select this one, and you can add files, but this data is not the blueprint data, is attached to this instance. So this is how the maintenance department use our product. Okay, so we are doing it, okay, perfectly. What we want to do in the future is to have Captor, to use some IoT stuff, to add also data that's coming from the real life of the product. We don't have it for the moment, but we can add everywhere on each individual instance specific data. Okay? So everything is open source, so don't hesitate to have a look on it. Right. Okay, thank you.